Hi guys, this is a section on 8.7, powers and roots of negative numbers. What we're going to do today is we're going to examine the effect of negative numbers on radicals. There are some aspects of this that is going to be a little bit confusing, and we just need to try to simplify it as much as possible, but there are going to be lots. It's going to be a wordy section. Just make sure you jot down any questions so that we can address them in class when you come back, okay? We're going to look at this activity first. It says work in pairs. Obviously, we're not going to do that. We're going to look at the graphs of some of these. Negative 2 to the x. And this is actually a type of function that we're going to talk about next chapter, so it's a way to start it off here. We're going to enter it into our calculator and generate a table with values. We're going to start at x equals 2 with an increment of 2, which that means your table, your delta x is going to be 2. Okay, that's if you're looking at the TI-84. I already got it going here on my TI Inspire. I graphed first, well, y equals parentheses negative 2 to the x power, and then I went ahead and looked at the table. It told me to start at 2 with my table step to be 2. Okay. And here are some numbers I have. Scroll through the table of values, compare the results of all 4 functions with your partner. Okay, so that's the first one. Now they also would like me to look at, let me go back to the graph here, hit tab. It says negative 7 to the x, so parenthesis, negative 7, get out of the parenthesis, caret, move this out of the way, x. Here's the next one, enter. Okay, your table should be here. I don't know if they're going to show them both or not. Menu, actions, view. I don't know where it shows me the table. There it is. Okay. I need to change the setup again. They want you to start at 2, and they want it to go by 2s. Okay. Okay, I don't need to do for the other 4. We're going to see the same thing. Basically, whenever I have the evens, this is the type of number I have. Now they also want me to change that to start at 1 and look at the odds. If I start at 1 and go by 2s, now all of a sudden the values I have are odds. Excuse me, negatives. Okay, so the lab asked, generate a table of values. So we had, first when he started with this, you had all positive numbers, and then when we had the start at 1, then we had all negatives. Complete the following generalization, choosing the correct words. Even integers with negative bases gave us positive powers, while odd integer exponents with negative bases gave us negative. This should make perfect sense to you. We have looked at geometric sequences this year, and if I would have just gone by ones, which I don't know why they really wanted you to go this way, let's just go by ones. It should flip-flop. Negative, positive, negative, positive, negative, positive. Why? Because what the function is actually requiring of me is to take negative 2 to the first. So negative 2 times negative 2. 1. Negative 2 times itself. 2 times. That's negative 2 times negative 2. The positives drop out. Negative 2 to the third. We're going to do this 3 times. Of course I'm going to get a negative when it's an odd exponent. This should make sense to you. Okay, so let's look at this. They want us to write negative 5 to the negative 4th without exponents. Use the product of powers postulate. They would like us to add the exponents since the bases are the same. Negative 4 plus 7, which is negative 5 to the third, which is negative 125. Okay. So what does happen when you have negatives and you're dealing with exponents or radicals? First of all, realize if the number underneath the radical is positive, then when you take the square root of it, you're going to get a real number. Okay? If I take the square root of a negative number, we looked at this in chapter 6, the square root of -4 was a pure imaginary number. Remember the i's. Okay, so it's 2i. So you could take a square root of a negative, but you're not dealing with a real number anymore. Instead, we're talking about imaginary numbers. So if both x and y are negative, we cannot apply the property that we talked about earlier this chapter where you could multiply them. This is why. Let's say I had the square root of -4 times the square root of -4. If I was to just multiply, that would give me the square root of positive 16, because -4 times -4 is positive 16, and then I would get 4. But is that really the case? Because what I have when I have the square root of -4 is 2i times 2i, which is 4i squared, which I squared is -1. It should be -4. So what's the answer? Is it -4 or is it +4? So that is why you cannot multiply whenever you have negative numbers under the square root sign, if that makes sense at all. So the answer should be -4. It's not +4 because this rule is not allowed whenever you have a negative under the radical. So that's what changes, okay? Now, if x is negative, then x to the n cannot equal x to the square root of x to the 2n. Basically, if you have a negative base, you cannot do the canceling stuff that we have looked at before, okay? The reason being the same as number 2. You will get negatives and positive. -2 to the third is -8. -2 to the 6th gives me a positive value underneath there, and when I take the square root of positive, I get a positive. We have sign change issues. Basically, what you need to keep in mind here is that when you have negatives under square roots, the shortcut rules don't really work. You need to look at it longhand way and see what you're dealing with. Are you going to have negatives? You need to take care of these imaginary situations first. Okay? These examples indicate that powers and roots of negative numbers have to be dealt with very carefully. For this reason, we do not define x to the m when x is negative and m is not an integer. So, we are not, no rational exponents with a negative base. It gets too confusing. Too many mistakes could be made. Okay, so we don't even address it in this book. You can't have a negative to a rational. It's not even defined for this textbook. You can square root a negative. You just need to keep in mind of the imaginary situation. Okay, so if this was the case, why is this not true? Well, the square root of -5 should be I root 5 times I root 11, which is I root 55, excuse me, not I, but I squared, because I times I is I squared. And so we should get negative square root of 55, and that does not equal I root 55, because that's what this would be. If you take out the negative, you would have I root 55. Here, we got negative square root of 55, so that is why it's not true. Okay, when x is negative and n is an odd integer greater than 2, so if we have a negative number underneath here, and you have odd roots. Odd root of a negative stands for the real nth root. This is okay. If you have an odd root, you can have a negative underneath it. Go back to what we know about odd roots. Odd functions look like this. There are negative values, and it gives you a real number out. It's going to be a negative. So if you take the cube root of -8, that's okay, because the graph of y equals x to the third looks like the snake. -8's down here. There is a real value where this works for. It is not true when you're dealing with even roots. That doesn't work with evens for the same reason. If I have the square root of -64, it has to be imaginary. Y equals x squared looks like this. -64 is down there. There's no real solution. Okay? It's an imaginary solution of the 8i. So here are some things you might want to jot down. Oh, don't want to do that. 2 to the 8th equals 256. 2 is an 8th root of 256, and it's a real number. -2 to the 8 is 256. -2 is an 8th root of 256. It is true, because there should be 2 of them on those. X to the 8th looks like this, 256 up here. There should be 2 answers, but keep in mind, if they give us this symbol, the 8th root of 256, we are only going to give the positive because they assign the symbol to positive values. If they wanted you to say negative 2, it would have said negative square 8th root of 256. That's how they'll let you know that they want the negative value. If they're giving you this symbol, and this will be on the quiz, if they give you this symbol, they only want the positive one. Even though there are 2 8th roots, the symbol square root 8th root is only asking for the positive one. Can't say that enough. Okay? Just the symbol. Negative 6 to the 3rd is negative 216. Negative 6 is a cube root of negative 216. Now what if it said 4th root? Could it be? No. You can't have a negative value that will come out of a even root. Okay, and this is how they write it here. 2 is the 8th root of 256. They're only talking about positive 1. Negative 2 is not the 8th root of 256 because they want the positive value. And here, it's not defined because you have a negative base and you can't have a fractional exponent or a rational exponent. But this is okay. So there's lots of things that some of the rules work, some of them don't. You're not going to be hammered so much on your test on notation, except they do want you to realize that that symbol has to be for positive values only. So what is the 5th root of negative 32? Is that okay? Sure. X to the 5th looks like this. Negative 32 is going to happen down here. It does work. It's going to give me a negative value of negative 2. Negative 2 to the 5th power equals negative 32. An odd number of negatives is going to give me a negative. That's numerically. This is graphically. Okay, the expression nth root of x when x is negative and n is even. If this guy is even and there's a negative below, things aren't going to work out. Okay? Unless it's positive. When x is greater than 0, if it's positive underneath there, it's going to be real. You can take an even root of a positive number, and it's going to be a real number. But when it's negative, it will not work. It only works for odd integers. Instead, you're not going to get any real value. You're going to get something imaginary. When n to the x and nth root of y are defined and are real numbers, so if they both work, then you can multiply. So basically, if this guy is going to be something that works and this is going to be something that works, then you can multiply them together if it's defined and real. So if it's an even and a negative, you cannot multiply. Look at the pieces first before you multiply them together. Write your answer in radical form. The cube root of negative 1250. Can I do this? Sure I can. Okay. The cube root of negative 1250 is the cube root of negative 125 times the cube root of 10. I can break this down because both of these are defined. The cube root of negative 125 is negative 5. Cube root of 10 cannot be simplified. It's just the cube root of 10 still. It is legal to do that because this is a real defined number. This is a real defined number. If it said the 4th root, could I do it? No, I couldn't break that down because there's no such thing as a 4th root of a negative. It won't be real. Y equals x to the 4th looks like this. Negative 1250 would be down here. It's not real, and this rule just says if they are real numbers and defined. So today is all about self-reflection. You need to ask yourself, is this a legal move to do? Is this a legal move to do? Draw a lot of pictures of graphs if you need to. There will be rules you could memorize if you wanted to about the odds and evens. I find it easier just to say if it's odd, it looks like this. Can I have a negative root here? Sure. If it's even, it looks like this. Can a negative be underneath there? No. Okay? If you have any questions, which I'm sure you will have a couple questions, jot them down and we can talk about them in class.